What's up guys, welcome back. In this video we're going to do some algebra using vectors. So if -3 times vector x plus 4 times vector y is equal to vector a, and 4 times vector x minus vector y is equal to 4 times vector b, express vectors x and vector y in terms of vectors a and b. So let's write out these expressions over here. So we got -3 times vector x plus 4 times vector y is equal to a. And then we got 4x minus vector y is equal to 4 times vector b. So what we got to do is we got to take these vectors x and y and express them in terms of a and b. So notice that right now we pretty much have vector a expressed in terms of x and y, and we have vector b, or 4 times vector b, expressed in terms of x and y. And if we wanted to isolate for that b, we could just divide everything by 4. Well, what you want to do in this case, we're sort of switching it around. So we want to get vectors x and y in terms of a and b. Is you want to start off by isolating for either x or y and then plugging it in to the other equation. So notice that we can start off by isolating this vector y here, right? I feel like that's the easiest one to do. So what we can do is we could bring this 4b over, so we'd have 4 times vector x minus 4 times vector b is equal to vector y. And then what you want to do is you want to plug in this expression for vector y into the other equation. So bringing this equation down here, we'd have -3 times vector x plus 4, and instead of writing vector y, we're now going to write 4 times vector x minus 4 times vector b, and that is equaling vector a. So now notice how we have an equation in terms of x, b, and a. And we're trying to express vectors x and y in terms of a and b. So notice how we can isolate for this vector x here. So we got -3 vector x, distribute this 4, so we'd have 16 times vector x minus 16 times vector b is equal to vector a. These here are like terms, that is 13 times vector x equals vector a, bringing this -16 vector b over, that would be +16 times vector b. And then notice how we can divide everything by 13. There's like a 1 in front of this a. So now notice vector x is 1 over 13 times vector a plus 6 over 13 times vector b. And notice that we've expressed vector x in terms of a and b. So we're done half the question. We've expressed vector x in terms of a and b, but we also have to express vector y in terms of a and b. So what we would do is the opposite. So instead of isolating for y, we now got to take one of these two equations that were given and isolate for x. So I'm going to use that same equation. So rewriting this here, we got 4 times vector x minus y is equal to 4 times vector b. And I'm going to isolate for this x here. So I'm going to bring this -y over. So I got 4 times vector x equals 4 times vector b plus vector y. Divide everything by 4. So vector x is equal to, the 4's cancel out here, vector b plus 1 over 4 times vector y. And now what we can do is we could take this expression for vector x and plug it into that first equation, because we used the second equation to isolate for x. So plug in that new expression into the first equation. So bringing this first equation down here, we'd have -3, and instead of writing vector x, I'm going to write this expression here. So vector b plus 1 over 4 vector y plus 4 times vector y is equal to vector A. And now notice with this equation here, we have vector B, vector y, and vector A. So we can isolate for that vector y, and it will be in terms of A and B. Notice that there is no more x vector in this equation. We took it out with this expression. So distributing inside the bracket, negative 3 times vector B minus 3 over 4 times vector y plus 4 times vector y is equal to vector A. Notice these are like terms here. So negative 3 over 4 plus 4, that is like 4 over 1. So that's like 16 over 4. So that is like 13 over 4. So basically these two are like 13 over 4 vector y. We could bring this negative 3b over. So that's going to equal vector A plus 3 times vector B. Notice we want to get the y by itself. So what we can do is we can multiply everything in this equation by the reciprocal of this fraction. Or we can divide everything by 13 over 4, which would be the same thing as multiplying by the reciprocal, right? When you divide by a fraction, it's like multiplying it by its reciprocal. So this would be multiplying by 4 over 13, multiply this by 4 over 13, multiply this by 4 over 13. So I'm going to continue this up here. So 4 over 13 times 13 over 4, notice that will just be 1, so we get the y by itself. And then 4 over 13 times vector A, notice there's just a 1 in front, so that would just be 4 over 13 vector A. And then 3 times 4 over 13, that's like 3 over 1 times 4 over 13, which is 12 over 13. That is vector B. And now notice how we got vector y in terms of A and B, and we also have vector x in terms of A and B. So vector x is 1 over 13 times vector A plus 16 over 13 times vector B. Then vector y is 4 over 13 times vector A plus 12 over 13 times vector